And here we go with our notes for mixed numbers and improper fractions. Again, this little mini unit before Unit 4 should be mostly a review, but some people really need it. So a mixed number is a mix, just a little way to help you remember, of a whole number and a fraction. So if I have 2.5, I would have two whole amounts colored in or considered, and a half. 2.5. So a mixed number is when you have it mixed as a whole number part and a fraction part. And you do say the word and in between because it's between the whole number and the portion part, just like when we do decimals. So 2.5. An improper fraction it's not very proper, is a fraction in which the numerator, that's the number on the top, is greater than or equal to the denominator. So therefore, if I have 5 halves, I would color in 5 halves, and then it would end up with the same amount as 2.5. So there's a half. There's a second half. There's a third half. There's a fourth half. And then a fifth half. So improper fraction. A lot of times we make our final answers into proper fractions. But there are times when we need to create improper fractions for various computations and comparisons and whatnot. So first we're going to go through the long, drawn-out process of how any mixed number could be broken up into all its fraction parts to figure out what it would be as an improper fraction. Then we'll talk about the shortcut, because you don't really have to show how it transforms. So it says a mixed number can be changed to an improper fraction by converting the whole number portion to a fraction with the same denominator as the fractional portion, and then adding the two fractions, because you'll have the whole number amounts of fractions and then the fraction part that you had. So if we look at 4 and 3/5, we have 4 plus 3/5. But 4 is the same as 4 over 1, so that I can turn it into fifths. On people's, I think it was their skill drills, sometimes you're saying times 5. And when we get into Unit 4, I'm going to repeatedly tell you it's not times 5, it's times 5 over 5. So that you're not changing your value. Versus if I make something 5 times bigger, it's definitely changing the value. So times 5 over 5 gives me 20 fifths plus the 3/5 that I had as part of my mixed number. And therefore, altogether, I have 23 fifths. So on yours, you shouldn't necessarily see, all those boxes and stuff. That was just formatting.
We don't have boxes.
That's what I just said. Thanks for repeating me. Okay, so here's the shortcut though. You don't have to actually break it out into, okay, it's going to come 25th plus the 3/5, and I'm going to combine them. I'm going to get. So instead, step 1, multiply the denominator by the whole number. And when we do the shortcut method, sometimes I'm going to actually remind you why it works. So multiply the denominator by the whole number. That tells you how much that whole number is worth as the fractional pieces. Step 2, add the numerator to the product from step 1. So the numerator of the original number, so that's how much you had as a fraction, plus what we just got as what the fractional amounts would be of the whole number. And then you put the sum, I didn't remember what we did from step 2, the sum from step 2 over the original denominator. So now you're saying, and that's how many pieces I have. And these are the size of the pieces. So when I'm doing this shortcut method, I kind of take it and I do like a little around the world looking thing. I go, okay, I do 3 times 6, 18. The reason I do that is because I know that 6 is the same as 18 thirds. but I don't really go through all that process. I go, okay, 3 times 6 gives me 18, plus the 2 that I already had. Now I have 20 thirds. That's supposed to be a 20. Ugly, ugly writing. So 3 times 6 got me 18, because that's how much 6 would be worth, 18 thirds. Plus the 2 thirds I already had, means I have 20 thirds. So around the world, I multiply, then I add, and I make sure I finish off at the bottom number. Who wants to tell me what 10 and 1/5 would be worth as an improper fraction? That gives me how many fifths, plus that fifth gives me what as fifths? Go around the world. Figure it out. And come back around, you get what?
51.
51 fifths. So 5 times 10 means 10 is worth 50 fifths, plus the 1/5 I had there, 51 fifths. Around the world. And then the last example here. 3 and 3/8 is worth what as an improper fraction? Yes, sir. 27 eighths. So I do the 8 times 3 because, whoa, hello. 8 times 3 because that's 24 eighths is the same as what 3 would be. Plus the 3/8 I had before gives me 27 eighths. Go around the world. And now it's funny because the quote-unquote notes for going the other way, we've already done it. It's just division. So let me clear off the notes from here. Does everyone have them?
Yep.
Filled in all the examples and all the little notations and whatnot. Clear? No. Yes. Whew. Wasn't sure if I was going to make it. If I had the space for it. No, no, no. Undo that. You, smartboard. Pay attention to where my finger is. Okay. Sometimes you have to talk to the technology. Alright, an improper fraction can be changed to its equivalent whole number or mixed number. You don't necessarily know right away if the numbers are a little bit more challenging. By dividing the numerator by the denominator. 5 thirds. You say, well, how many thirds do I have in 5?
1 and 2 thirds.
1, and then I have 2 thirds left. So you divide. How many thirds do I have in 5? That's 1, and I still have 2 thirds left. You're just dividing. The next one, how many 4s do I have in 125? You might end up doing a little long division on occasion. So go ahead and show their long division. We're dividing 4 into 125, but as a mixed number quotient. We've had the option in the way past of doing remainder quotient. We have the option this year of doing decimal quotient. But we want a mixed number, so we're going to come up with a mixed number quotient. Yes, ma'am, in the back.
31 and 1/4.
3, that's 12, that's 0, bring down to 5, you got the 1, that's a 4, then the 1 left, so 1/4. 31 and 1/4. And the last one, 27 eighths. You think about how many eighths are in the 20, because the reason we're dividing it out is we're thinking how many 8/8 are in there, because every 8/8 gives me a whole. So how many 8/8 means I'm going to see how many whole number parts are, and then how many are left for the fraction part. So 27 eighths is equivalent to what? Back corner.
3 and 3/8.
3 and 3/8. I use the same number as before. But again, if you want to think it fractionally instead of division-wise, it's because we're figuring out how many 8/8 can I take out of there. I can take 3 of them out, but then I have 3/8 still left over. 3 and 3/8. So once you have your notes completed,